Question 2.1. Describe how molecules are ionised using electrospray ionisation. So this is in a time-of-flight mass spectrometer. Well, first of all, you've got to purify the liquid sample. It needs to be dissolved in something that's polar, a volatile solvent, such as water or methanol. So it's going to be dissolved in something like water or methanol. Polar, so that it will dissolve in it. Volatile, so that it will have a low boiling point. The solution is pumped through a hypodermic capillary needle, so it goes through a very fine needle, and the sample is converted into a fine mist. And when it comes out of that needle as a fine mist, a very high voltage is applied to the tip of the capillary, and that forces each of the particles to lose an electron and form a plus charged fine droplet of liquid. Give the form of the ion that reaches the detector first on the time-of-flight mass spectrometer. It's going to be the lightest one. So if you calculate the MR of each of these particles here, molecules, then C3H5O2N is the one with the lowest MR, the lightest one. Sample of germanium is analysed, given an equation using state symbol for the process that occurs during the ionisation of a germanium atom. Well, it's the first ionisation energy, so you've got a germanium atom GE. It's got to be gaseous. We've already determined that it comes out as a fine mist, so the liquid is made into a gas, into a fine mist, and then it loses one electron and forms GE+. It's still as a gas, and you've got to do the electron as an E- to balance the equation. 2.4. So you've been given a lot of information. So in a time-of-flight mass spectrometer, you should know, it's given here, kinetic energy is half mv squared. So kinetic energy is half mv squared, and the kinetic energy is given to you here, kinetic energy 4.238 times 10 to the minus 15. So that equals half mv squared. So what I've done is I've multiplied both sides by 2 and to get mv squared, and then the length or the distance is 96 centimetres. That tells you here 96.00 centimetres. You need to convert that into metres, 0.96 metres. So this is another equation you've got to learn. Quite often you're not given this, that velocity is distance over time. If you think about driving a car, and your speed or velocity is in miles per hour, miles is a measure of distance, hours is a measure of time, so speed or velocity is distance divided by time. So the distance that's travelled is 0.96 metres, I've got that into metres. The time, it tells you here, somewhere it tells you time reaches the detector in 4.65 times 10 to the minus 6 seconds. That's correct. It should be in seconds. 206,274 is the velocity. So v squared is this value squared, 4.25 times 10 to the power of 10. So now I can substitute this in. So now I can work out mass here, because I've got v squared, I've got kinetic energy, I can work out mass. So it's the mass is 1.147 times 10 to the minus 25, and that's the mass of one particle. It's one particle in kilograms, so if I multiply by Avogadro's number, it gives me the mass of a mole, 6.91 times 10 to the minus 2 kilograms, multiplied by 1,000, 69.1 grams is the mass of 1 mole of this substance.